right, perfect. All right, sweet. So, yeah, let's get started. So, my name's Lewis, and I'm one of the fellows for Pod 2.0.2, aka Kinetic Kowalskis. And yeah, we're in the open source track. And today, my show and tell is just going to be a brief talk, debugging 101, a little bit of focus on Python, a little bit of focus on the tooling, most popular tooling available for Python. And yeah, just try to hopefully I can learn something out of this presentation and you guys can learn something out of it too. So without further ado, I'm going to go to the next slide. So just to discuss the agenda for today, I'm just going to talk briefly what is debugging, some fun facts. Then I'm actually going to do a little bit of a deep dive into how to debug in Pycharm and Visual Studio Code. And then I'm just going to make some final closing remarks. All right, so I always love to start these talks, or well, being my first one, I always like to start with a nice wall of text. So the formal definition for debugging is, and from Wikipedia, in computer programming and software development, debugging is the process of finding and resolving bugs, aka defects or problems that prevent correct operation within computer programs, software, or systems. Debugging tactics can involve interactive debugging, which we'll cover, control flow analysis, unit testing, integration testing, log file analysis, monitoring at the application or system level, memory dumps, and profiling. That's a long laundry list of things that are available to you for debugging. Many programming languages and software development tools also offer programs to aid in debugging, known as debuggers. And here's the short and sweet answer to debugging from Felipe Fortes. This is actually pretty funny. Debugging is like being the detective in a crime movie where you are also the murderer. Of course, because we're always breaking stuff as we build. Good stuff. So a little bit of history and some fun facts. So bug itself, it's a term that's used to describe any faults within an engineering project. It could be in computer science, it could be in across the full threshold. And here I just coined the first quote by Thomas Edison in 1878, over 100, almost 150 years ago. I'll skip over that, but I'll just mention that oh, the actual term bug was coined, etc., for computer science when a Mark II electromechanical computer had a moth stuck in one of the capacitors, which was halting proper functionality. And later, the term was adopted into computer science in the early 1960s. So, let me just wind back to some of the terms that I discussed in the first set of slides. So interactive debugging is the usage of a debugging tool, such as the debugger provided by Vscode or Pycharm, to step through a program, analyze the code, etc. Control flow analysis is more of a static tool. You're actually looking at code blocks and you're trying to determine, okay, how is this code block being entered to? How is it being exited? And try to, see in a way that you can match, bigger scale bugs across multiple modules. Unit testing is something that hopefully we're all very accustomed to in any programming language. The usage of manually written software tests or even automated to test a block of code against a variety of inputs, reasonable, unreasonable, try to cover a wide berth and a reasonable berth. Integration testing is somewhat related to unit testing. Same idea, instead more focus between the interface between code blocks. So like if I have a function A that interfaces with function B and I want to do an integration test, what I can do is I can write a test that uses both function A and function B in a use case. Um, I don't want to go too much into detail of use cases, but more like how it's actually used, how A communicates to B, and what the output is, and whether that is something that we expect. Next is log file analysis, which again is more static, analyzing logs generated by a program, even while it's running, or sometimes when the program crashes. We want to see what were the steps that the program took to crash, and sometimes this is very useful for safety critical programs. So I mentioned often employed in post-mortem analysis and in predicting code behavior. You can think of them as print statements. Monitoring is related to log file analysis, and I just extract the quote in verbatim. The extraction of information from a running system and using it to detect and possibly react to absurd behaviors, satisfying or violating certain properties. So I guess to give you like a simple example of this, whenever you're looking at a pressure gauge, you can see that the pressure in a tank. You can see how it rises or it falls, and you can react accordingly. We're almost done. Memory dumps, viewing the memory space taken up by a running program. It's sometimes used in post-mortem analysis. This is very important, especially when you're dealing with sometimes low-level system programs such as C, and you want to see like where did I get this segmentation fault? If you guys understand, segmentation faults is just when the running program that you use tries to use memory that has not been provided to it, that it has not gained access to in advance. Profiling is the analysis of the execution of code, focusing primarily on bottlenecks and identifying sources of performance gains. So a simple usage of that would be maybe you realize that your program is running very slowly for some inputs, and you want to run a profiler to see, okay, which code blocks are running really slowly and how can I improve that? So I'm just going to focus on interactive debugging, but hopefully this serves as a good starting point in terms of concepts that you can grasp for any further learning. All right. So more terms in interactive debugging. I'm just going to focus on the main three that I'm going to touch on today. I'm going to make the slides available for everybody else so you guys can check them out on your own. And I also try to make references to the sources I did for research so you can read up more. But the main three things that I want to focus on for today, a breakpoint. So hopefully you can see my mouse here. It's the third point. Uh, I define it as a manually chosen line which, when encountered, causes execution to pause for analysis. So if I place a breakpoint on, say, line 9, what the debugger is going to do is it's going to hit that line and it's going to pause execution for me, giving me the opportunity to do whatever I want to analyze the running program. The second one that I want to talk about is step. This is a control which allows the debugger to run a single line, then pause execution. This would be the sixth definition on the screen. And the last one that I want to touch on, and you guys may have used this at the beginning of your Python learning, is interactive console, which is a special facility which allows the entry of commands for analysis. An interactive console could be the Python REPL or the interactive Python console, which I'm going to show you with Pycharm and Vscode. Um, Perfect. So why is interactive debugging important? Of course, having robust, reliable software is highly important. This is especially important if the software that you're writing manages safety critical systems such as nuclear reactors, or even software that you submit for your hackathon submission. You don't want your stuff to get glitchy when you're showing to judges. And we also want to avoid this. I'm just going to show you guys a 10-second video of a very important software failure that was very expensive. I don't think I'm sharing my computer audio, but that's okay. So, and by the way, if you guys know what this rocket is, if this reminds you of anything, this is pretty funny, in my opinion.
Tous les paramètres propulsifs sont normaux et la trajectoire est normale.
Bam. Okay, so why did I just show you a rocket exploding in midair? So that was the Ariane 5, the successor of the Ariane 4 rocket. And in short, what happened in this situation was the Ariane 4 was a very successful rocket that was used for space exploration. And what happened with the Ariane 5 is basically the software engineers, they made it a faster rocket, but they forgot to include code that would adapt to a faster rocket. So what happened here was the rocket itself was traveling at a speed so high that the counter that was designed to fit the actual value of the speed number overflowed. So that led to the restarting of the control system in the rocket, which led it to say, okay, I want to turn back to Earth. And it did it so violently that the rocket just broke into itself. So we don't want that happening. All right. So next 2 points, unit testing, integration testing, if there had been a check to see what happens when an integer overflow happens, that could have prevented this. Um, Interactive debugger also helps us further. I'm going to cover 2 key cases. What happens when you're unsure of the operation of the program, like when you're trying to navigate through an API, or you're simply messing around with code. So we're almost at the debugging part. So how to debug? It often starts with setting a breakpoint, like I talked about. It also could start with analyzing an exception. When the program crashes, you want to take a look at what variables had their values set. So we'll dive into Pycharm's debugger first. So the example that I decided to choose was exploratory programming. So this is more whenever you're jumping into a new API and you want to use the debugger to try some things out, try to see how the program behaves to, some of the software decisions you're making. Of course, when learning new APIs, we generally use how-to guides, documentation, maybe even looking at the tests if we have them available, or even looking at the source code itself. Sometimes we have cases of reverse engineering where we literally take an executable and decompile it into source code. However, it's usually more helpful to have the original source code where we have the programmer's comments because then we can see, okay, maybe there's some things that we didn't know about. So yes, we can use a debugger to explore an API and play around with code. Let's try it in an exercise. So we're going to jump into Pycharm. All right. So I'm just going to blow this up. So in Pycharm, what I did was I just created 2 simple API functions, generate list and generate dictionary. And these are just silly examples. It's nothing crazy. Um, what this is just going to allow us to do is just see how at the actual debugger we can play around with things. We can see, okay, what works, what gets me the output that I want, and so forth. So here, sample list, we just use generate list and we pass it any amount of entries, 1, 2, 3, potato hamburger, a float, and that will get us a list. This will work. However, in sample dict, we are going to get an error, and I'll show you guys that in a bit. So I'm just going to run to main, and I'm going to show you guys the error. So the error that we get here, generate dictionary takes 0 positional arguments, but 1 was given. So what does that mean? We gave it the 1 positional argument sample list, and we're going to try to see how we can use this function to get to our goal. So I'm going to give you guys, we have a question from Boyan. Sorry, I'm seeing it a little bit. Is interactive console PDB in Python? So I think it was mentioned in PDV from our previous talks that that's also a possibility. PDB itself is built into the Python library, so it is usable. However, I won't be touching over it today. Hopefully that answers your question. So for this next part, I'm just going to direct you guys to the show and tell discussion or even the chat in the Zoom call. I'm just going to ask you guys, try to think of one thing that you do to try to fix this. You can include the stuff that I mentioned in the previous slide. Boyan, I think Ori will go over the PDB. Yes, yes, he will. Okay, I'll start with one thing. Look at the source code of generate dictionary. Okay, yes. So we can do that. Let's make it a little bit harder. What happens if we don't have access to the source code or it's closed source software? Maybe there's documentation.
Yeah,
Tests.
there is a session by Ori at 10 p.m. IST today on Python PDB.
Yep, I'll just put that in the chat. On PDB. Yeah, and I think it was sent out in the calendar invite. Okay, so anyways, what I'm just going to jump into is actually placing a breakpoint here, running the debug button, jumping right into this. So here I have sample list. I have some values here. What I'm going to do is I'm going to switch over to the console. This is actually pretty cool. What it allows you to do is it allows you to type any command on Python and you'll get your output. So if I want to do 2 plus 2, I'll get 4. Simple as that. So what I can do is if sample dict or if generate dictionary isn't expecting any positional arguments, maybe I can try something else. Maybe it's accepting keyword arguments. So let's try hey equals sample list. Okay, so that actually didn't return an error. So we actually got a dictionary where the key was hey and the value was the list that we provided. Okay, so that kind of gets us somewhere. What happens if we'd like to go a little bit deeper? Maybe what I'd like to do is for each entry in the list, I want to generate a key with the same value. Can anybody just pop it in the chat? I think everybody's going towards what I'm thinking. Okay, what I was going to say is the simplest thing you could do is just do an iteration over the list and then just call string on the entry and enter it like that. So I think what I can do here is for entry in sample list, maybe I want to scratch this. Let's make it sample list 2 equals empty list, and then for entry in sample list, what I'm just going to be doing is I'm just going to be calling the string method on sample list and putting it into sample list 2 as a tuple, and then I'm going to see if I can pass those tuples into generate dictionary. So I'll just make it nice and clean. Tup equals none. You know what? Sample list 2 dot append. And what I'm going to do is stir entry. Append takes exactly one argument. Okay, perfect. So good thing I can just add brackets here. Okay, perfect. So if I want to print sample list 2, so here we have. I have a list of tuples, and then what I can do is I can just pass it into generate dictionary. See if this will work. Okay, perfect. Okay, so the main trick here was, and I got stuck on my own simple, silly example, was that generate dictionary only takes keyword arguments. So it somehow defeats the point a little bit because it's expecting a dictionary representation of your values. Yes, use a list comprehension. That would have been a good one-liner. Yeah, so anyway, so that's, being able to place a breakpoint wherever you run into an exception and just type out stuff, play around with the code, that's something very useful. It's facilitated by Pycharm, it's facilitated by the interactive Python interpreter. So, hopefully you can get use of that. So yeah, that was a little bit of a silly example. So anyways, I have some notes here in case we got stuck. The second example is actually using the debugger to find bugs. So the main concern in debugging is in finding bugs within your program. Like I said, you can invoke it in any execution context. What we're going to do is we're going to look at it in Vscode. And I'm going to show you a different code piece. All right, so here I have a slightly more complicated example, and I do have the tests available. I also have our main class available. So what I'm going to do is I'm going to run the tests. I'm going to make sure that I'm in the bug branch. Good. So I'm going to run the tests. Whoops, that's not what I want. I'm going to run the tests. Look at the test output. Let's see. It's not really working. What I'll just do is I'll just run the tests and get it to show in the output here. All right, and I don't want to debug, I just want to go. Okay. So it seems what we're getting here is we're getting a key error for some reason from pandas. So why don't we jump into the functions and look at the source code? Main. This is our entry point. What I will be looking at is the function itself. Okay. So let me make this easy for us. What this function actually does is it just gets you the distance between any 2 points in two-dimensional space. So what we usually do is we run get Euclidean distance. And what this does is it takes two pandas data frames. The data frames are just, overkill pretty much with what I did. Uh, it just has to have a row that has a name y and a row that has a name x. Okay. And what we're going to do is we're going to take those two rows, assume that they're integers, and then return the distance from one point to the other. And what we do here is we use the get square root function instead of using Python's built-in square root. And this just recursively computes the square root to a reasonable tolerant divergence. So let's take a look at the error here. So we get a key error capital X. Let me switch back to init.py. It looks like it's in line 16 from the tester. Okay, it looks like it's here. So it looks like somebody tried to print the rows. However, they didn't take into account that the creation of the 2D point would be in lowercase, okay? So this kind of just highlights why I try to stay away from using print statements. Sometimes when you use a print statement, you stick too closely to the definition of the data type, and dumb things like these can happen where you access something, maybe it was capital X in the past, but now it's not. So let's get rid of that. And let's try it again. And I have to save the file, of course. Okay, so it's going to run it. Okay, so it correctly prints. And now we get some weird errors here. Actually, I think that was just because I was too trigger happy with the debugger. Let's just run it. Okay, that's actually interesting. Let's take a look at the trace. Thread. Cannot recover from Stack Overflow. Okay. This is interesting. Where could we get a Stack Overflow? Can you guys tell me? I got an unexpected error. Actually, it kind of is expected because somewhere recursively. Okay, yes, the square root recursion. I kind of gave it away. Okay, so how could we get a Stack Overflow here? Maybe the tolerant divergence is too small. Just looking at this analytically, what do you think could be going wrong? What I'm taking here is I'm just getting new x, which is x plus a over x. And just to give you a little bit of background, a is the original number that we want to get the square root. X is our closest approximation to the square root. So what do you think is going on
Yeah,
here?
it's never reaching like less than the tolerant divergence.
Yeah, that would be it, because otherwise we wouldn't go into the recursive call. Okay, in the interest of time, what I will notice is here I'm using Python's floor division. So what this does is
Got
it
it.
completely
Yeah.
chunks off the fractional part of our number. So if I were to remove that, that should help. Okay, let's give it a try again after saving the file. So that was just an example of static analysis right there. Okay, pydev. Okay, so we're still getting a Stack Overflow, which is somewhat interesting. It might be another issue that I may have created when I was checking this out. I could be square rooting too much. Anyways, I'll skip a little bit in the interest of time. So the main thing that we want to check here is tolerant divergence. So yes, what happens is it looks like tolerant divergence is actually not small enough. We want it to get smaller enough so that we can get something closer to the approximation that we want at the square root. There also is an issue in the way that intermediate y and intermediate x are computed. So if we had added a little bit more comments in our code, it would have been easier for me to explain offhand. But what's going on here is intermediate y and intermediate x. Basically, it's the difference between the y's and the x's of each point. What I'm doing here is instead of subtracting each one and then not doing anything else, I actually power them to the power of 2 and then send them to get square root. This is also wrong, by the way, because the Euclidean distance or the Pythagorean distance is, as we all know, a squared plus b squared equals c squared. But what's happening here is we're actually squaring the values before too early, and then we're just adding them. So that's also wrong. And the debugger would have actually helped us get through here. And the way that you actually use that in VS Code, if I just run the test here, so we pause here, we can take a look and see that, we've started from test Euclidean distance. That was the first start. We jumped into this first assert. We're in to get Euclidean distance, and right now, if we have points, if we have row 1, row 2, let's print out row 1. So it's 0, 0, 0, so it's at the origin. Row 2 is 1, 1. So technically, the difference for intermediate y and intermediate x, it actually looks like it could be correct. Intermediate y is 0, 1. Anybody that has experience with pandas data frame, what does that tell you? Okay, I'm just going to say it right here. So this is intermediate y. Okay, so it's 0, negative 1. What if I do just row 1? It's going to get me xy. But if I just want to get the row part of it, if I ever try to get that row part, row 1 y, I have to cast it to an integer. Otherwise, if I just get row 1 y, it's going to get me, and for those of us who know pandas, this first number right here, that's the index. Then x, y have entries for that index. So what I do here with row 1 y, I get the index and the value. That's not what I want. I just want the integer. So yeah, that's probably going to be a little bit more of a nefarious bug, but if you jump into the debugger and actually see, like when you print out row 1 of y and you say, I want to get an integer, that's not really what I want, right? I want the integer itself. What happens if I cast it to an integer? We get this value here. So, silly things like that that might get you in your code, caught by your, extensive unit testers. VS Code debugger looks painful. Ouch. You're going to have to tell the Microsoft devs about that. It actually doesn't look too bad to me. But yeah, just anyways, like being able to jump into here, print out on the debug console what's going on, that really helps a lot. All right. So now that we've gone a little bit of deep diving into VS Code and Pycharm, what I just want to make sure, and going back to Anand's point, it's always important to just play around with what's available. I just showed you two, and I just showed you like not going too deep. VS Code, PyCharm, you can try more. There's other debuggers available for any languages that you want. I think IntelliJ, they create a bunch of software IDEs, for Java, Ruby, etc. So that allows you to play around with the debugger, or if you like that debugger, then you can stick to it. But basically the core, at least in my opinion, the most important stuff are breakpoints, having a call stack, being able to trace memory in terms of being able to see the variables and being able to run Python commands. That's really important. There's also a lot of other debugger software available, one built into Python called PDB, command line debugging. So whenever you are maybe SSHing into a remote computer and you want to debug, that gives you the possibility. On a side note, there's also PDB++, which adds more functionality to it. That's going to be actually in tomorrow's talk by Ori, so that's going to be cool. I'm going to be there. Anyways, other tools to help you in determining buggy code. So debugging is not, the cut the grass. For example, Git lens allows you to check changes in code that, maybe somebody else broke, and you just want to see what change was made to that code to break it. And last but not least, debugging is only one entry in a plethora of effective tools to help you navigate code writing and testing. Most importantly, be willing to get out of your comfort zone and just get ready to have fun. Happy hacking.